Jim McGregor, TIRIAS Research, here with Sasha, and we're going to see some demos today. So what do we got?
So this is our covert protocol tech demo. It's a demo that we put together to showcase how some of our ACE NIM models can be integrated into something that looks like a AAA game title, to give game developers an idea for how they could take AI models and integrate them into games. So what we have in this demo is a couple of different characters that you can interact with very naturally just by speaking into the microphone. And we then use speech recognition to translate that into text, which then gets sent into a large language model that creates a response, which then gets fed into a text-to-speech system that creates audio for the response, and then that audio gets piped through our audio-to-face model, which creates lip syncing and facial animation for that. So all of that very complex sounding pipeline results in this.
Welcome to Hotel Whopper, sir.
Hello, what's your name?
The name's Bond. Just kidding. It's actually James. What can I do for you, sir?
What can you do for me?
Well, I can give you a warm smile and a friendly hello. And if you need any assistance, I'm your guy. Just don't ask me to carry any more luggage. My arms are about to fall off.
So each character is set up with a backstory and a character profile. So rather than in traditional game development, you would write up dialogue scripts and you would have dialogue trees and conditional logic to figure out which line to say when. Here, it's really all about building out your character, fleshing out what the character profile is, what his personality is like, what his backstory is, and then feeding that into the large language model so that his responses are always in context of what his role is, both his actual role in the game, but also within the confines of this game world, which is why he will mostly talk about luggage and bellboy activities, since that's his job. But you can still talk about anything that you want to talk about. You can throw nonsense at him and he will still give you a response. For example, if I say something like, should I wear a purple shirt or a green one?
He's thinking.
Purple is always a power move, sir. But
There
if you
you
want
go.
to make a statement, go for the green.
So obviously, this is demonstrating ACE and the
Right.
digital human capability. So when we talk about NIMs, do you have to put that in each, because this is a lot of different complex models that you're entering. Do you enter each one of those as a separate model, or is it one complete model that you're entering?
So right now there's separate models,
Yeah.
because often you want to mix and match
Yeah.
different models, and you want to choose whether you run them locally or in the cloud. So for this demo, we're actually running two of the models locally on the machine that's sitting underneath. So the speech recognition is done on device, and the facial animation through audio to face is done on device. But then the large language model and text to speech are done in the cloud, using ChatGPT 3.5 Turbo for the language model, and 11 Labs for the text-to-speech backend. But you could use other models. You could use smaller language models that you can actually run on device, or train a small language model specifically for a game context and only with the knowledge that is in that game world, because ChatGPT has way more knowledge than any game developer would ever want in a game. There's all this context in there that's really irrelevant for building game lore or the game world.
And when you say on device, we're talking about running on the RTX GPU.
Right.
So how large of a model do you think you're running here in terms of parameters? Because obviously we're talking about AI PCs here at Computex, but we're talking maybe 40 tops for most of the SoCs, where we're using a GPU that has much more performance here. So could I run this on NPU?
Not really in its current form. A lot of the models are small, other than the large language model, which really is by far the largest model with the most parameters. the speech recognition is actually very small that you could definitely run on an NPU. I mean, any smartphone these days has built-in speech recognition if you use, Siri or Google Assistant or any other voice assistant. They all do speech recognition on device. And then the audio-to-face model is also considerably small compared to the language model. So it's really the language model where you need the most optimization and train smaller language models or have a customized model that gets fed with, like in this case where we have a knowledge base, like a RAG database essentially, that helps flesh out the characters and feed them the knowledge that they need to have specific to them without having to retrain the language model.
So I still need the GPU to really run that LLM.
Right.
Yeah. Okay. Thank you.
But as Jensen said during the keynote, since we've been shipping RTX GPUs for several years now, there is a fairly large install base worldwide now that can run these models on device. And as new generation of cards come out and the models get smaller and more efficient, you'll be able to run more and more of these workloads on your device. Just how we've seen it with graphics capabilities and real-time ray tracing, these things that initially were confined to the high-end GPUs and the high-end machines, and then found their way into the lower-end graphics GPUs. You'll see the same happening with AI as well, where as the lower-end cards keep getting more tensor cores and more AI capabilities, it'll open up the abilities to more and more end users to execute these models locally.
Perfect. Thank you.
Sure.